This video contains a brief overview of what polynomials are. We will go over very quickly what a polynomial is, how to operate with polynomials, in most operations anyway, and then we will finish up with what quadratic expressions or quadratic functions are, and that'll just be a closing which will lead into another video to come soon. So without further ado, a polynomial is an expression or a function in the form, here it is, a sub n x to the n power plus a sub n minus 1 x to the n minus 1 power plus dot 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 all the way down to a sub 0. So the takeaway here is the a sub I, so any of these up here, I will circle those in blue, any of these numbers here, or any of these variables, can be any real number that's positive or negative. So if this a sub n minus 1 ends up being a negative number, we could just write minus here. So, a sub n x to the n power minus a sub n minus 1 x to the n minus 1. So we just have to make sure that they're real numbers and that the exponents on all of the x's, which I will circle up here in red, have to be positive whole numbers, or I guess non-negative whole numbers. That means we're allowed to have x to the 0 power 1, 2, 3, 4, 5. And just by looking at this, you may wonder, or you may notice that there is no x to the 0 power up here. You see 1, 2, and these are whole numbers. But the x to the 0 power is kind of hiding way back here, x to the 0 power, like this. And we normally don't write it because x to the 0 power is just 1. So we would be multiplying here a sub 0 times 1, and that's just a sub 0. So we don't ever write it, but it can be there. And then some important words that I will be incorporating throughout the next few slides are degree, coefficient, term, and constant. So the degree is the biggest exponent for x. The coefficient could be any number in front of an x variable. A term is the entire piece between plus and equal or minus signs. So a sub n x to the n power. It'll be easier to explain what a term is when you see an example. And then a constant is any term without a variable. So this last one would be considered a constant. Okay, so here we will be talking about combining polynomials, and we can talk about the degree and the leading coefficient, which is something I did not mention on the last page, but it is just a specific coefficient. And then we can talk about what the terms are as well. So with combining polynomials, when you're adding or subtracting polynomials, you will just distribute any constants or coefficients or terms that are outside of a set of parentheses and then combine like terms. So this is going to be as simple as noticing there's a 1 here and there's a 1 here, and we can distribute these ones, and essentially all that is going to do is get rid of the parentheses here. So we have these this new expression, and in order to add these two polynomials together, we followed the first step, which was distribute. And now I just have to combine like terms. And we like to start with the biggest exponent first. So here I see I have an exponent to the fourth, x to the fourth power, exponent 4. And I want to write that term first. 5x to the fourth. Now I want to check as well, is there anything here that can be combined? Are there any other x to the fourth powers that you see? I don't see any. All right. So next, What's the next biggest power? I see x squared and x squared. I have two of them here. So x squared, there's a positive one of these, and there's a minus 2x squared here. So going back to the last slide, defining what a term is a sign, a coefficient, that's the number in front of the x variable, remember, and a variable with a power. So a sign, a coefficient, a variable with a power. Now we can combine the like terms if the variables have the same power. So x squared, we can combine these together, and when we do, we only combine the coefficients. So plus 1, minus 2, that combines to minus 1, and the exponent does not change. So we've taken care of this term, we've taken care of these terms that can be combined. Let's check what's next. It looks like here I have a minus 5x, and there aren't any other x terms that can be combined with that. All I have left is a 2 and a 7. And so we can combine the 2 and the 7 to make 9. And so this is the answer here. So from the previous page, we can talk about how many terms. This has 4 terms because we have a sign, a coefficient, a variable with an exponent. That's 1. We have a sign, a variable, and an exponent. That's 2. We have a sign, a coefficient, and a variable. That's 3. We have a sign and a number. That's 4. So this last term here would be what is called the constant term. It has no variables to it. And we can also talk about the degree. The degree will be the biggest exponent x has, and in this case, it's 4. So we could say this is a 4th degree, 4-term polynomial. Okay, so with these other 2 examples, I'm going to go a little bit quicker. For example, 2, it says subtract. Now, mind you, there are still 1s here. So I'm going to multiply all this first polynomial by a 1, and I'm going to multiply this second polynomial by a negative 1. And that's how we will get rid of the parentheses. So we will have 6p cubed minus 5p squared minus 2p plus 7. Over here with the second polynomial, I have negative 1 times 5. Negative 1 times 5 is negative 5p squared. I have negative 1 times 6, which is negative 6, and I have negative 1 times negative 7p to the 6th power, and that is positive 7p to the 6th power. And you may notice that I was only multiplying the coefficients here by the negative 1. So again, I like to start with the biggest exponent to get my answer all in what we call standard form, or the exponents will be in descending order, just like we did up here. 4, 2, 1, no x's. Descending order for the exponents. So the biggest exponent I see here is 6. So I'm going to write that term first, 7p to the 6th. Do I have anything else that I can combine with that? Any other p to the 6th powers? No. All right, so we're done there. What's the next biggest term? I see this one here, p cubed. Are there any other p cubeds? No, so that'll be a plus 6p cubed. Next, I have this minus 5p squared. Are there any other p squareds? Oh yeah, here. So we have negative 5p squared minus 5p squared. So these 2 terms here actually combine to negative 10p squared. If you have a minus 5 and another minus 5, minus 5 more is minus 10. Don't get confused. Don't try to make it a 0. Next, we have a p to the first power here. Yeah, there aren't any other p to the first power, so I've got minus 2p. And lastly, I have this plus 7 and minus 6. So when you combine those two together, you get a plus 1. And that is the answer for the subtraction here. And we can say, hey, this is a 6th degree polynomial. That's the biggest exponent I see. That has 1, 2, 3, 4, 5 terms. So with this last example, just one direction, it says combine. So we have to take care of any distributions we can have first. So this would be minus 3p minus 6 plus 4p squared minus 19 minus 20p squared plus 10p. Cool. Oops, I just realized this. This should not be 19. This should be 76. I'm glad I caught that before I went too long. So this is 76. So let's see. Biggest exponent I see here is 2. And I have 2 terms with that. So I'm just going to combine the coefficients in front. 4 minus 20 is negative 16p squared. That takes care of that and that. Next I have exponent 1. So I've got a negative 3 plus 10, that is plus 7p. It takes care of that and that. And then I have a minus 6 and a negative 78. I think that should be negative 82 because that's a 76, not a 78. And so here we have a 2nd degree polynomial, or you can say polynomial with degree 2, that has 3 terms. For this slide and for the last operation that we will be doing with the polynomials is multiplying polynomials. And all you need to do here is multiply the first term of the first polynomial to each term in the second polynomial. And then you just repeat that step for each other term in the first polynomial. So what that looks like, and I'll do it nice and drawn out this first time. We have 5x times x plus 5x times negative 4. And then we would take the second polynomial, or the second term of the first polynomial, plus 2x cubed times x plus 2x cubed times negative 4. And that is a lot of work, but we can combine some things here, so we shall combine some things here. X times x gives us x squared, and we're done with that term. Positive 5 times negative 4 is negative 20, and we still have an x left over, so that has to be part of the answer for that one. So we're done here. Plus 2 times 1 is 2. X cubed times x is x to the 4th power. And then I have a time, so we're done with that one. Then I have a 2 times a negative 4 is negative 8 x cubed. So we're done with that one. And you can do these multiplications in your head. Don't be afraid to do that if you are good at that. So you could have jumped right from 5x times x is 5x squared, and 5x times negative 4 is negative 20x. And you move to the next term in the first polynomial. 2x cubed times x is 2x to the 4th. 2x cubed times negative 4, negative 8x cubed. You don't need to write down all this stuff out. I did that just so you could see how the distributions worked. Anyway, Final step here, we like to write things in descending order, so let's do that. There would be 2x to the fourth minus 8x cubed, because this is the biggest exponent, the next biggest exponent, plus 5x squared minus 20x. And this is the standard form of the multiplication of all that. Just to show you another example, this one requires a little more work. So we will do this. Let's take 5x cubed and multiply it to everything in the second polynomial. And I'm just going to write this first one out the whole way so you can see what's going on. We will have 5x cubed minus 2x, times negative 2x to the negative first power. Don't be scared by the negative exponent. You'll see what happens here in a second. Plus 5x cubed times 6x squared plus 5x cubed times negative 1. All right, so all this stuff is going on here. We have 5 times the negative 2 is negative 10. Ooh, so we took care of that and that. But what do we do with these here? It turns out you can just add the exponents together. So 3 plus a negative 1 would just be 2. And that's how we're going to approach these the rest of the way. And it works here too. Let's see, plus 5 times 6 is 30. X to the third power times x squared. If we add those together, x to the fifth power. And that's exactly what I was doing in the last example. So here we have 5 times negative 1 is negative 5. X cubed, yep, that's it, x cubed. So the first bit of this answer would be negative 10x squared plus 30 x to the fifth minus 5x cubed. So now we can jump to the next term. And I'm going to multiply negative 3 times negative 2 and get a positive 6. And I'm going to multiply x to the fifth times x to the negative 1, which means I can just add those exponents together and get x to the fourth. So then I can just do the same thing. I'm going to multiply negative 3x to the fifth times 6x squared. So multiply the coefficients. That's negative 18. Right? Negative 3 times 6. And add the exponents of the x's together. 5 and 2 make 7. And then I need to take negative 3x to the fifth one last time and multiply it to negative 1 to get positive 3x to the fifth. And I can do something very similar here, here, and here to get negative 2 plus 6x cubed minus x. And now we have this great big mess down here, which requires us to combine like terms. And again, we like to do this in descending order. So start with the biggest exponent, negative 18x to the seventh. I don't see any other x to the seventh power, so I'm going to start with that one. Let's see, the next biggest exponent of x would be 5. Oh, I see, I have a couple terms with x to the fifth. So I need to combine those together. So I have 30 and 3 more. That would leave me with a plus 33x to the fifth. So not there, we're done with that. I think the next biggest exponent then would be x cubed. So I see I have a couple of those, which means I just need to combine the coefficients in front. 6 minus 5 is 1. And normally we don't write the 1 in front of the x, so I'm just going to leave it like that. Oh, I missed an x to the fourth. All right, let's back up. 6x to the fourth, that would be the next one. Then we have the plus x cubed. All right, there we go. Next would be x squared. I only have one term with an x squared, so that'll be minus 10x squared. And then I have an x to the first power right there, minus x, and then I have a constant minus 2. So there is the answer for the multiplication of that one up there. Oof. So the multiplication can take a lot longer than the adding and subtracting, but there's a very sound algorithm to make sure you do it correctly every single time. On to the last slide. Probably the most common polynomial you will run into in your mathematical career is a quadratic polynomial. So there are a couple rules for quadratic polynomials. The first one is it must be a polynomial. I mean, if it's not a polynomial, then it can't be a polynomial. Sounds weird. Just go with it. And the degree of this polynomial has to be 2. That's what makes it quadratic. It has to have a degree 2, and it must be a polynomial. This means it can be written in the form f of x equals ax squared plus bx plus c, and a can't be 0. Another way this could be written, if you see a quadratic equation, it could be 0 equals ax squared plus bx plus c. So this is an equation here, and this one up here is a function, and you can tell because of the function notation. But there will be a separate video for this. Good luck.